Hello viewers, I'm Kausalya. Today we are going to solve problems related to superposition theorem. The problem is using superposition theorem, find the current in the resistance R3 in the circuit shown below. So this is the given circuit diagram, and in this circuit diagram we are asked to calculate the current that flows through this resistance. Okay, this resistance R3 is of the value 1 ohm. So here you see we are having one current source, okay, 20 amps. So 15 amps goes out by this way and 5 amps goes out by this way, right? So when we can use superposition theorem? We can use superposition theorem only when we have more than one source, right? Minimum, the circuit should consist of two sources. Then only we can make use of this theorem. So here what we are going to do is, you see, assume the above circuit has two current sources, right? So, but in the circuit there is only one current source, but here we are assuming the circuit has two current sources. So, one current source is of value 15 amps, right? It enters at A and leaves at C. And another current source of value 5 amps that enters at A and leaves at B. Right, that is we are splitting this 20 as 15 and 5 because here we are having these two outlet currents of values 15 and 5. Right, so the first step is we are considering our 15 amp source alone. So when you consider 15 amp source, you see remaining the rest of the diagram remains the same here. Right, so now when we analyze, okay, you just keep this AC, this thing as such here, right? Because the current enters through this path and leaves through this path. So you just keep this 1 ohm as such, right? So now when you look at this 2 ohm and 6 ohm, how they are connected? This 2 ohm and 6 ohm are connected in series, right? How can you say that these two elements are in series? Because you see the current which flows through this path again flows through this path because here there are no more paths to divide. So the current flowing through these two resistors remains the same. Okay, so these two are said to be in series. So here this 2 and 6 ohm are in series, and again the same way you see this 3 and 5 ohm are also in series because the current that flows through this 3 ohm will flows through this 5 ohm also. So 3 ohm and 5 ohm are in series. So we are calculating the net value of resistance. So you see 2 plus 6 gives 8 and again 3 plus 5 gives 8. So we are redrawing this diagram. So when you redraw this diagram, you see between A and C we are having 1 ohm, and again between this A and C we have combined these two resistors, right? So here the value is 8 ohm, and again between A and C, that is these two resistors are combined, and here we are getting 8 ohms, right? And the next thing is, you see, these three resistors are in parallel, right? Now we are going to combine these two resistors. So what is the formula to find the value of equivalent resistance? So the value is, the formula is R1 into R2 divided by R1 plus R2. So that gives a value of 4 ohms here. Right. So therefore here we are having a 4 ohm resistor, and between this A and C, this 1 ohm resistor, it remains the same. Right. Then we are going to calculate the current that flows through this 1 ohm resistor by using the current division formula. So here current division formula is nothing but total current into opposite resistance. The resistance which is opposite to this 1 ohm is 4 ohm. So 15 into 4 divided by total resistance is 1 plus 4. Right. So that gives the answer as 12 amps here. Right. Now when we consider only 15 amp source, the current flowing through this 1 ohm resistor is 12 amps. Right. Now we are proceeding with the 5 amps current. Right, when you consider the 5 amp current, you see here 5 amps current entered through this point and it leaves at point B. Right, so in this case, again the thing is we have to keep this 2 ohm resistor as such, and we have to reduce the remaining resistors. Right, so again the first thing is, you see this 3 ohm and 5 ohm are in series, right? So the total resistance value will be 3 plus 5. That gives the answer as 8 ohm. Right. So once you reduce this, you see our circuit will be like this. Yeah, here I have drawn already. So again, this resistance will come in parallel with this 1 ohm resistance, right? You see. Between A and C, 1 ohm. This 1 ohm is drawn as such, and now I had combined these two as a single resistor whose value is 8 ohm. So these two are in parallel. Right. And the next thing is we are again going to redraw the circuit. So for this parallel combination, what is the value of effective resistance? It is 0.9 ohms, right? R1 into R2 divided by R1 plus R2. Right. So again, when you redraw the circuit here, you see this is your 2 ohm resistor. This is drawn as such, and this 6 ohm resistor is also drawn as such. And here these three resistors are now transformed into a single resistor whose value is 0.9 ohms. Right. Again, when you look at the circuit, you see this 0.9 and this 6 ohm are in series. Right. Because you see the current flowing through this 6 ohm again will flow through this 0.9 ohm. So the same current flows through these two resistors. So these two are said to be in series. So how to find the total resistance? It is given by 0.9 plus 6, that gives the answer as 6.9 ohms here. Right. So again when you redraw the circuit, you see this series combination, okay, is connected in parallel across this A and B points. I hope you get. These two resistors are combined as a single point, right? Single resistor, and this resistor is connected between points A and B. So again, this 2 ohm resistor is also connected between A and B. So when you redraw the circuit, you see these two resistors are in parallel. Right. Now again by using the current division formula, we are calculating the current that flows through this 2 ohm resistor. Right. So again the formula is total current into opposite resistance divided by total resistance. Here 2 plus 6.9. So that gives the answer as 3.88 amps. Right. But what we actually need? We actually need the current that flows through this 1 ohm resistor. Right. So let the current flowing through this 2 ohm resistor is calculated as 3.88. Then what about the current that flows through this 6.9? So 5 minus 3.88 will give you the current that flows through this 6.9 ohm resistor, right? So whose value is 1.12 amps. So here we are redrawing the circuit like this, right? So let me explain how we have drawn this circuit, right? You see, current flowing through this 6.9 is calculated as 1.12, right? Where comes this 6.9? This 6.9 comes from this 6 and 0.9, right? And how does this 0.9 ohm occurs here? This 0.9 ohm comes from 1 ohm and 8 ohm, right? Can you get? So in the same way, we had just redrawn the circuit, right? So here, okay, between A and C we are having 1 ohm, and again between A and C we will be having 3 ohm and 5 ohm, right? Since they are connected in series, it is nothing but our 8 ohms here, and here the remaining 6 ohm, right? Even you can neglect the 6 ohm, okay? No need of this. So now we need to calculate the current that flows through this 1 ohm resistor. Again by using the current division formula, total current into opposite resistance divided by total resistance. So that gives the answer of 1 amps here, right? So when you consider 5 amp source, the current flowing through this 1 ohm is 1 amps. Again, when you consider 15 amp source, the current flowing through this 1 ohm resistor is 12 amps, right? Now, the total current that flows through this 1 ohm resistor is calculated as 12 plus 1, which is equal to 13 amps. Right. So here comes the end of this problem. If you have any doubt related to this, let me know in the comment section. Thank you.